All right, today we're putting the four titans of AI through what we're calling the 2026 Gauntlet. We're going to stack up OpenAI's ChatGPT, Google's Gemini, Anthropic's Claude, and xAI's Grok against each other in a series of really intense, practical showdowns. So forget all the marketing hype for a minute. We're here to see who actually cracks under pressure. You know, we see leaderboards and benchmarks pop up constantly, and they're useful, to a point, but they really don't tell the whole story. They test these models on clean, single-shot tasks. But what happens when the requirements change right in the middle of a project? Or when a model has to follow super strict safety rules? Or, and this is a big one, recover from its own mistakes? The real world is messy, and that's what we're here to test. So here's how we're going to break it all down. First, we'll meet our four main contenders. Then, we're throwing them straight into a three-stage gauntlet, a complex coding challenge, a safety-critical rules test, and then a final trial of autonomous thinking. And at the very end, we'll tally up the results on our final scorecard to see which model you should actually be using and for what. Okay, let's quickly introduce the four major players stepping into the arena for our 2026 showdown. I mean, these are the models at the absolute cutting edge of the industry right now. First up, of course, is the one that really started this whole thing, ChatGPT, now running on GPT 5.4. It's kind of the undisputed champ of versatility. Its biggest strength, hands down, is its massive ecosystem. You've got the GPT Store, DALL-E 3, Sora 2, video integration, the whole shebang. It's the default jack-of-all-trades for general knowledge work. Next up, we've got Anthropic's Claude with its flagship model, Opus 4.6. Now, Claude has really carved out a reputation as the professional's choice, especially for developers and writers. It powers a ton of high-end coding tools and is just known for producing incredibly precise, natural-sounding text, all with a massive 1 million token context window. And in the third corner, we have Google's Gemini 3.1 Pro. This is the model that consistently tops the charts on all those abstract and scientific reasoning benchmarks. Its real superpower, though, it's that deep, native integration into the entire Google ecosystem. Search, Workspace, Android, you name it. If you live and breathe Google, Gemini is built for you. And finally, we have the disruptor, xAI's Grok 4.2. Now, Grok has two really unique advantages. First, it has real-time native access to the fire hose of data on X, which makes it totally unmatched for news and social sentiment. And second, it boasts a staggering 2 million token context window, the largest in the industry by a long shot. All right, with our contenders introduced, it is time for Challenge 1. And this isn't about just writing some simple script. No, we're testing if these models can handle a complex, multi-step coding task where the rules literally change halfway through. The big question is, can they adapt without breaking everything they just built? For this, we're actually using a multi-turn benchmark from a group called Snapper AI. So the AI gets a coding task, and after it submits a solution, boom, we add a totally new requirement. The real test isn't just solving each piece, but adapting the whole project without messing it up. This kind of staged reasoning is, believe me, incredibly difficult for current AIs. Now, what's really fascinating here is how this exposes a kind of hidden weakness. Grok 4.2, that real-time powerhouse, absolutely aced the simple one-shot tasks, perfect passes. But the second we added that extra adaptive step in the multi-turn benchmark, it just fell off a cliff. A hard fail on one of the tasks. It just goes to show that great baseline performance doesn't guarantee success when things get complicated. But hey, Grok wasn't the only one to struggle here. Claude Opus 4.6, the supposed coding specialist, had a really spectacular failure on this refactoring task. It didn't just make a small mistake, it completely misunderstood the project structure and moved the wrong function into the wrong file. As the researchers at Snapper AI pointed out, for a premium model, that is a very costly and pretty surprising miss. Okay, let's move on to our second challenge where we are raising the stakes a lot. We're now asking these AIs to generate code for safety-critical environments. I'm talking automotive, aerospace, medical devices. In these fields, following strict rules isn't just a good idea, it can literally be a matter of life and death. For this, we're diving into a fascinating technical report from Middle East Technical University. They tested several AI models against something called the MISRA C standard. Essentially, you can think of MISRA C as the absolute, definitive rulebook for writing safe, reliable C code for embedded systems, like the software running your car's brakes. It's all about preventing weird behaviors that could lead to catastrophic failures. And the results revealed this amazing compliance paradox. So just look at Gemini. Beautiful, working code with almost no rule violations. Perfect. Now look at ChatGPT and Claude. ChatGPT's code worked every single time, but it consistently broke at least one rule. And then there's Claude. It was so focused on following the rules that it produced completely broken, non-functional code 2/3 of the time. It followed the rules, but forgot to make the code actually work. And this brings us to our final and, honestly, our most difficult challenge: autonomous thinking. We're not just asking the AI to write code anymore. We're asking it to act like an agent, to use tools, to execute multi-step plans, and, most importantly, to recover when things go wrong. This is really the frontier of what AI can do. To really get this challenge, we have to talk about a concept from the researchers at Mind Studio. They call it the AI model tipping point. And it's basically this critical threshold where an AI model becomes reliable enough that giving it autonomous tasks actually saves you time. Below this point, you're just debugging its failures all day. But above it, these agents become genuinely productive. So why were those early AI agents so frustrating to use? Well, they pretty much failed in 4 key ways. They'd slowly drift off task and forget their instructions. They'd try to use tools with commands that didn't even exist, just pure hallucination. On a long project, they'd completely lose track of the main goal. And crucially, if a tool gave them an error, they'd just get stuck in a loop, totally unable to fix it. And this right here is why that tipping point is so incredibly important. See, the failures compound on each other. So if you have a 5-step task and each step is a pretty good 80% reliable, your chance of the entire task succeeding is just 33%. That's it. For these agents to actually be useful, each step has to be nearly perfect, like 99% reliable. The newest generation of models is finally starting to hit that level, which is making these complex agent workflows a real possibility. So after running our contenders through this whole gauntlet, what's the final verdict? We've seen them struggle with complexity, we've seen them paradoxically fail by following rules too well, and we've seen them push the boundaries of autonomous thought. The most crucial point here is that the best AI really, truly depends on the specific job you need it to do. Let's just break it down nice and simple. If you need the best all-around balance with the biggest library of tools and integrations, ChatGPT is still your go-to. For professional-grade software engineering and serious writing, Claude really takes the lead, thanks to its precision. Now, if your work involves heavy scientific or abstract reasoning, Gemini's top benchmark performance makes it the obvious choice. And for anything involving real-time news, social media, or analyzing absolutely massive documents, Grok's unique access to X and its giant context window are just unbeatable. So as we've seen, this isn't a race with a single winner. It's really about an evolving landscape of specialized tools. The question isn't who is the best. The right question is who is the best for this specific task I need to do right now. The key is to understand their unique strengths and weaknesses and to choose your tool wisely. Thanks for joining us for this explainer.